In this example, we're given this trigonometric equation, and we're going to go ahead and verify that these two values for x are going to work. So they're valid solutions. If you'd like to go ahead and give this a try first, go ahead and pause the video and do so, and then come on back and we'll work it together. Okay, so looking at this equation, I would like to see if pi over 12 will be a solution of this equation. So we're going to use direct substitution. And I'm going to go ahead and plug pi over 12 right in here for this value of x. So what we'll see is 4 times the sine squared of 4 times, well, that pi over 12, and minus 3 equals 0. So 4 times pi over 12, well, the 4 and the 12 can cancel. And really, I'm going to be left with pi over 3. So let's go ahead and write that down. So pi over 3 minus 3 equals 0. Well, maybe you don't like to work with radians. Maybe you would prefer degrees. So we'll go ahead and kind of work through and talk about at least both ways. So 4 times the sine squared of, well, pi is 180 degrees divided by 3 will be 60 degrees. In either case, the sine of 60 or the sine of pi over 3 is going to be the square root of 3 over 2. But of course, that was being squared, so we need to make sure we keep that squared right up there. So minus 3 equals 0. Okay, so the square here, I'm going to square the numerator and square the denominator. So what I'm left with is, well, 3 over 4. And the way we got that 3/4 is the square root of 3 squared is, well, 3. And then 2 squared is 4. And we'll see these 4's will cancel, and that's nice. So what we're left with is 3 minus 3 equals 0. So 0 equals 0. And that works out. So we can see with direct substitution, this first value, pi over 12, will indeed be a solution for this equation. So let's go ahead and do the same thing, but we'll use x equals 5 pi over 6, and we'll just rework it once again using direct substitution. So we'll plug 5 pi over 6 right in there for that value of x. So we have 4 times sine squared of 4 times 5 pi over 6, and minus 3 equals 0. So we can do a little canceling here. So the 4 and the 6, I can factor and cancel a 2 out, so 2 and 3. And 2 times 5 is 10. So it looks like I have sine squared of 10 pi over 3, and that's minus 3 equals 0. Well, 10 pi over 3, what's that going to be? Well, if pi is 180 degrees, and we divide that by 3, that's 60 degrees, times 10 is actually 600 degrees. But 600 degrees is kind of out of our 0 to 360, one rotation. So let's go ahead and take 360 away from that 600 degrees. And so really what that ends up looking like is 240 degrees. And again, that work again, 10 pi over 3 is equivalent to 600 degrees, but that was outside of our normal single rotation, so I went ahead and subtracted 360 to get this terminal angle of 240 degrees. Alrighty, so what is the sine of 240 degrees? Well, we know that's going to be negative square root of 3 over 2, and of course we have this squared right there. So doing this squaring, we see that the negative gets squared, so that guy goes away. Square root of 3 squared is 3, and 2 squared is 4, just like we saw in the previous value. So these 4's cancel, and 3 minus 3 is 0. So 0 equals 0. And we see that this also is going to work. All right, so through direct substitution, we went ahead and we verified that both of these values of x are actually solutions to this trigonometric equation, and we did so by inspecting both the values in radians and degrees. Kind of just depends on which one you're more comfortable using.